Hello there, and welcome. Tonight I want to take you somewhere, a place that exists not in maps or atlases, but in the vast terrain of human curiosity and cosmic mystery. I want to invite you into a journey through the darkened corridors of space itself, where light travels eternally, where time bends in ways our everyday minds struggle to comprehend, and where questions linger like stars in the velvet night. You're about to embark on an exploration of one of the most captivating paradoxes ever conceived by human thought, a mystery that has fascinated scientists, philosophers, and dreamers for generations. It's a question that seems so obvious at first, so simple in its asking, yet holds within it layers of complexity that reach into the very fabric of reality itself. Imagine, if you will, that you're lying there comfortably, perhaps in darkness, perhaps with just the gentle glow of starlight filtering through your windows. The world outside is quiet. The night is deep and peaceful. And in this quiet moment, I want to whisper to you a question that has haunted humanity's imagination. What if there was a shortcut through space? What if somewhere in the cosmos there existed pathways that could bend the ordinary rules of travel and distance? What if wormholes, these mysterious tunnels through the fabric of space-time itself, could be our answer to the deepest barrier we face as a species, the speed of light, that universal speed limit that seems to stand between us and the rest of the universe? But here's the thing, and this is where the real wonder begins. We finally discovered why wormholes could never actually beat light speed travel. And yet, this discovery isn't disappointing. No, far from it. It's beautiful in the most unexpected way. It reveals something profound about the nature of our universe, about the elegant rules that govern existence itself, and about our place within this grand cosmic design. As we journey through these hours together, we'll uncover this mystery together. We'll explore what wormholes truly are, why they seemed like the perfect solution to our cosmic wanderlust, and why the universe, in its infinite wisdom, has protected itself and us through physical laws that are both humbling and magnificent. Before we dive deeper into this cosmic ocean, I want to take a moment and acknowledge something. I hope you're settling in nicely, getting comfortable wherever you are right now. Perhaps you're in your bedroom, perhaps somewhere else entirely. But I'm curious, where are you watching from tonight? What's the time where you are? Is it late evening, deep night, or perhaps early morning? I'd genuinely love to know. If you're enjoying this cosmic journey, if you're finding yourself drawn into this exploration of wormholes and light speed and the mysteries of space-time, please take a moment to like this documentary. It means the world, truly, because it tells us that people like you care about these questions. It tells us that the mystery of the cosmos still calls to human hearts across the globe. And if you're the kind of person who loves these cosmic journeys, who finds themselves awake in the night wondering about the universe, please consider subscribing. Join our community of cosmic explorers and curious minds. Drop a comment down below and tell us where you're watching from and what time it is for you. Let's connect across these vast distances, just as light connects across the stars. Your comments matter. Your presence matters. You're part of this cosmic conversation. Now let me tell you something about the way our minds work when we think about space. There's something deeply embedded in the human psyche, something that reaches back through millennia of history and reaches forward into our future as a species. We are creatures who look up. We are creatures who wonder. From the moment our ancestors first gazed at the night sky and saw those pinpricks of light burning in the darkness, something stirred within us. A yearning, a curiosity, a fundamental desire to understand what lay beyond our immediate world. The stars have always represented something more to us than just distant balls of burning gas. They've represented possibility. They've represented the unknown. They've represented freedom itself. Think about it for a moment. Throughout human history, whenever we've encountered a barrier, we've sought to overcome it. When mountains stood in our way, we climbed them. When oceans separated us, we crossed them. When the sky seemed to be the limit, we learned to fly. And as our knowledge grew, as science revealed the structure of our universe, we came to understand that space itself, the vast, unimaginable expanse between worlds, represented perhaps the greatest barrier and the greatest opportunity of all. The distances are so immense, you see. They're almost impossible for our minds to truly grasp. The nearest star to us, Proxima Centauri, is about 4.25 light years away. That means even traveling at the speed of light, the fastest anything can possibly travel, it would take 4 years and 3 months to reach it. And light, of course, travels at 300,000 kilometers per second. Nothing we know of can move faster than that. But here's where the dream was born, where hope took root in the minds of theoretical physicists and visionary thinkers. If there existed shortcuts through space, if there were ways to fold the very fabric of space-time like you might fold a piece of paper, bringing distant points closer together, then perhaps we could overcome this seemingly insurmountable barrier. Perhaps we could explore the galaxy, reach distant worlds, maybe even contact other civilizations without having to wait centuries or millennia for our ships to arrive at their destinations. This is the dream that captured imaginations. This is the hope that took form in equations and theories. This is the wormhole, a concept that seemed to offer a way around the speed of light limitation itself. And it's not just a modern fantasy, you understand. Humans have always imagined ways to transcend our limitations. In ancient myths and legends, we see recurring themes of magical doorways, portals that connect distant lands, pathways that circumvent the normal laws of travel and time. Perhaps these ancient stories were our way of expressing something deeper, a fundamental human intuition that the universe is more flexible, more wondrous than it might first appear. And then, in the 20th century, Einstein came along and rewrote our understanding of space and time itself, and suddenly, the wormhole wasn't just fantasy anymore. It became something that might theoretically exist within the framework of our best scientific theories. This is what makes the story so compelling. This is what makes the journey we're about to take together so worthwhile. We're not just exploring abstract physics, we're exploring human hope, human imagination, and the beautiful way that reality sometimes teaches us that our limitations are actually gifts in disguise. The story of wormholes and light speed is ultimately a story about us, about our place in the universe, about the questions that define us, and about the extraordinary grace with which the cosmos seems designed to keep us safe and grounded within its embrace. As we continue now into deeper waters, I want you to remember this. You're not just listening to scientific explanations. You're participating in a cosmic meditation. You're taking part in a contemplation that has engaged the greatest minds in history. And your presence here, your willingness to wonder, your openness to mystery, all of this matters. It contributes to the great human conversation about existence and meaning, and our relationship to the infinite universe around us. So continue with me. Let's explore together. Let's ask these questions that keep us awake in the night, and let's find peace not in definitive answers, but in the beautiful uncertainty and endless wonder of it all. The night grows quieter still as we prepare to venture deeper into these mysteries, and perhaps, as you listen, you'll find yourself drifting between states of consciousness, between full awareness and the gentle approach of sleep. Let that happen. Let yourself float with these ideas. Let the cosmic perspective settle over you like a blanket, warm and comforting. Because the more we understand about how vast and complex the universe truly is, the more we can find peace in the present moment, in the beauty of this planet we call home, in the precious opportunity we have to exist and wonder and explore, even if only in our minds and hearts. Before we move forward into exploring what wormholes actually are at a deeper level, I want to pause here for a moment and ask you something important. If you're still here with me, if this cosmic journey is resonating with you, if you've found something fascinating or beautiful in what we've discussed so far, please let me know. Drop a comment in the section below and tell us what's captured your imagination. Is it the concept of shortcuts through space? Is it the mystery of how the universe might be organized? Is it the philosophical question of our place in the cosmos? Your thoughts matter, and reading them, knowing that people across the world are thinking about these same questions, it creates a connection that transcends distance itself. It's rather beautiful when you think about it. We're all separated by vast distances, yet connected through curiosity about the cosmos. And so we press forward, deeper into the night, deeper into the mystery. The universe awaits our questions. The stars continue their eternal burning, and somewhere in the vast darkness between them, the answers we seek are dancing with possibilities we haven't yet imagined. You and I, we're on this journey together now, and that's a rather extraordinary thing, isn't it? Now, let's talk about what wormholes actually are, because understanding this is essential to understanding why they could never actually beat light speed. You see, a wormhole isn't something that simply exists out there in space, waiting to be discovered like an island on a map. No, it's far more subtle and profound than that. A wormhole is a theoretical structure that emerges from the very equations that describe the universe itself, the equations of general relativity that Einstein gave us over a century ago. And to understand what a wormhole is, we need to first understand what space-time itself is, and this requires us to think differently about the fundamental nature of reality. Imagine, for just a moment, that space and time aren't separate things. They're not time over here and space over there. Instead, they're woven together into a single fabric, a four-dimensional continuum that physicists call space-time. This isn't just a mathematical convenience or a way of thinking about things. According to Einstein's theory, this is how the universe actually works at the most fundamental level. Space and time are inseparable. They're aspects of a single underlying reality. And this fabric, this space-time, can be curved, warped, and distorted by the presence of matter and energy. This is gravity. Gravity isn't a force pulling you down, as Newton suggested. Rather, it's the curvature of space-time itself. Massive objects like the Earth curve the space-time around them, and we experience that curvature as the sensation of weight and downward pull. Now picture space-time as a vast, smooth sheet. Imagine it as an infinite rubber sheet stretched out in all directions. When you place a heavy ball on that sheet, it creates a depression, a curve. That curve affects the motion of other objects nearby. Similarly, stars and planets curve space-time around them. But here's where it becomes truly fascinating. What if space-time, in some regions, could curve in very specific ways? What if, through some extraordinary circumstance, space-time could fold back on itself in such a way that two distant regions were suddenly connected by a tunnel, a passageway through the fabric itself? This is the wormhole. It's sometimes called an Einstein-Rosen bridge, named after Einstein and another brilliant physicist named Nathan Rosen, who first described such a mathematical solution to Einstein's equations back in 1935. The idea is elegant in its simplicity. If space-time can curve around a star, creating what we see as gravity, then perhaps space-time could curve in other ways too. Perhaps it could form a kind of tunnel, a shortcut through space itself. Imagine folding a piece of paper. If you have two distant points on that paper, they're far apart. But if you fold the paper in half, bringing those 2 points close together, you've created a shortcut. A wormhole would work similarly. It would be a fold in space-time itself, a way of bringing distant locations closer together geometrically. The mathematics that describe wormholes are beautiful and strange. They emerge naturally from Einstein's field equations, which describe how space-time curves in response to matter and energy. The equations don't forbid wormholes. In fact, they allow for them. They suggest that under certain conditions, space-time could form these tunnel-like structures. For decades, physicists treated wormholes as interesting mathematical curiosities, fascinating solutions to the equations, but probably not something that actually existed in the real universe. It seemed like they would require exotic forms of matter, perhaps with negative energy density, that we'd never observed and probably didn't exist. But as time went on, as our understanding of the universe deepened, as we discovered stranger and stranger phenomena, neutron stars and black holes and dark matter and dark energy, the idea that wormholes might actually exist somewhere in the cosmos seemed less and less absurd. Maybe, just maybe, the universe was far stranger and more wonderful than we'd imagined. Maybe wormholes were out there, waiting to be discovered, offering pathways through space that could allow us to traverse vast distances. And if that were true, if wormholes existed, then perhaps we could use them. Perhaps they could be our answer to the problem of cosmic distances. Think about how extraordinary that would be. Instead of traveling in a straight line from Earth to a distant star, taking thousands or millions of years even at light speed, you could find a wormhole and use it as a shortcut. Instead of going the long way around, you dive into the wormhole at one mouth and emerge from the other mouth near your destination. The distance through normal space might be immense, but the distance through the wormhole might be manageable. You could reach distant worlds in reasonable time frames. You could explore the galaxy. You could contact other civilizations. The whole cosmos would open up to us. This was the dream. This was the hope that kept physicists studying wormholes that made them seem worth investigating despite their apparent implausibility. And this is the hope that leads us to the central question of our journey tonight. If wormholes could work as shortcuts through space, could they somehow bypass the speed of light limit? Could they allow travel faster than light? This question haunted theoretical physicists for decades. It seemed like maybe, just maybe, they could. It seemed like maybe wormholes offered an escape route around Einstein's ultimate cosmic speed limit. But as our exploration deepens, as we delve further into the mathematics and the physics, we're going to discover something remarkable. We're going to find that the universe is protected by deeper symmetries than we realized. We're going to understand that the speed of light limitation isn't just a simple rule that can be bypassed with the right trick. It's something far more fundamental, woven into the very nature of causality and time itself. But before we get there, before we reveal why wormholes could never actually beat light speed, we need to understand something essential: why we've always yearned to escape the boundaries of our world, why the speed of light seems like such an injustice to our cosmic ambitions, and why the dream of wormholes captured our collective imagination so powerfully. We need to understand the human story behind this scientific question, because at its heart, the story of wormholes and light speed isn't really about physics at all. It's about us. It's about our dreams, our limitations, and the extraordinary way that reality teaches us to find beauty in what we cannot change. As the night deepens and you settle deeper into comfort, into that space between waking and sleeping where thoughts become dreams and dreams become thoughts, consider this. We are creatures of limitation. Our lives are finite. Our reach across space is infinitesimal compared to the scale of the universe. We can barely leave our own planet. We can send robots and instruments to nearby worlds, but the idea of human beings traversing the galaxy seems almost impossibly distant. And yet, we dream. We imagine. We ask, what if? And in that asking, in that questioning, we participate in something profoundly human. The urge to transcend our boundaries and reach towards something larger than ourselves. The wormhole represents that urge in its purest form. It represents our hope that somehow, somewhere, the universe will bend to our needs, will offer us a shortcut, will let us be more than our limitations would suggest. And perhaps, as you continue deeper into this journey, you'll find that the universe does offer us something. Not shortcuts through space, perhaps, but something more valuable. It offers us understanding. It offers us perspective. It offers us a sense of awe and wonder that makes our brief time in this existence feel precious and meaningful. The story of why wormholes could never beat light speed is ultimately a story about accepting the universe as it is, about finding grace in our limitations, about learning to see that sometimes the barriers we face are actually the most elegant and beautiful aspects of reality itself. So let your mind float now on these cosmic currents. Let the questions wash over you like gentle waves. Let yourself drift with the idea of space-time and wormholes and light traveling across vast distances. The night is deep, the universe is vast, and you are here, conscious, aware, able to contemplate these mysteries. That is perhaps the greatest shortcut of all, the ability to traverse the cosmos through thought, to reach distant worlds through imagination, to connect with the infinite through the power of human curiosity. Now we journey deeper still into the realm of human aspiration and the ancient roots of our cosmic yearning. Because the story of wormholes doesn't begin with Einstein or modern physics. It begins much earlier, in the hearts and minds of humans looking up at the stars and wondering what lay beyond. The dream of escaping our planetary boundaries, of reaching out to touch other worlds, is as old as human civilization itself. In ancient times, before we had any scientific framework to explain the heavens, our ancestors wove stories about celestial realms, about gods and goddesses who could travel freely across the cosmos, about magical pathways that connected distant lands. These stories weren't just entertainment, they were expressions of a deep human need, a yearning that seems hardwired into our consciousness, the desire to transcend our limitations and explore the unknown. When we look at the great explorers of human history, the seafarers who crossed oceans, the explorers who ventured into unknown lands, the pioneers who pushed into uncharted territories, we see this yearning expressed again and again. Humans are, by our very nature, creatures who seek to expand our horizons. We're driven to overcome barriers, to reach beyond what we thought possible, to discover what lies on the other side of the mountain or across the sea. And as our knowledge grew, as we came to understand through science that we live on a small planet orbiting an ordinary star somewhere in an ordinary galaxy, among billions upon billions of other galaxies stretching out to the cosmic horizon, that yearning took on new dimensions. It became a cosmic yearning. The distances are what make it so poignant, you see. They're so vast that they're almost incomprehensible. The nearest star, Proxima Centauri, is 4.2 light-years away. A light-year, for those who might not be familiar, is the distance light travels in a year, about 9.5 trillion kilometers. 4 light-years means roughly 38 trillion kilometers. That's an almost unimaginable distance, and that's just our nearest neighbor. The next star is much farther, and the galaxy as a whole, the Milky Way, is 100,000 light-years across. To cross it at the speed of light would take 100,000 years, and beyond our galaxy there are billions of others, some of them billions of light-years away. The scale is incomprehensibly vast, but humans, we're dreamers. We don't accept barriers easily. We look at those distances and we ask, can we overcome them? Can we find a way? This is the spirit that led us to develop faster and faster forms of travel. We went from walking to riding horses, we invented wheels and built roads, we harnessed the power of water and wind with boats and sails, we developed steam engines and locomotives, we created automobiles and airplanes. Each innovation brought distant places closer. Each technology made the world seem a little smaller. And with each acceleration we ask the same question, what's the limit? How fast can we go? Is there something faster? For most of human history, the barrier we faced was simply the Earth itself. The speeds available to us, walking, running, riding, sailing, were measured in tens or perhaps hundreds of kilometers per hour. But in the 20th century, something extraordinary happened. We learned to fly. We broke the sound barrier. We developed rockets and launched ourselves into space. For the first time, human beings left the surface of the Earth. We reached the moon. We sent robotic probes to every planet in our solar system and beyond. We've sent our creations farther than we could have possibly imagined. The Voyager spacecraft are still transmitting data from the edge of the solar system, traveling at speeds of 17 kilometers per second, and even at that incredible velocity, they would take tens of thousands of years to reach another star. And that's when the limitations became undeniable. That's when we came face to face with what seemed like an ultimate barrier. No matter how fast we could make our rockets go, no matter how much we improved our propulsion systems, the distances to other stars were simply too vast. With our current technology, a journey to the nearest star would take hundreds of thousands of years. The star Sirius, one of the brightest in the sky and relatively nearby at only 9 light-years away, would require about 500,000 years to reach with our fastest spacecraft. The human mind recoils from these timescales. They're almost meaningless in historical terms. They're longer than human civilization has existed. They're longer than our entire species has existed on Earth. But then came Einstein, and with him came a new understanding of the universe. Einstein showed us that space and time weren't fixed and absolute as Newton had believed. They were relative, flexible, woven together into a 4-dimensional fabric called space-time. And in his equations, in the mathematics that described how space-time curved and moved, there appeared solutions that seemed to describe something extraordinary. Structures through which space could fold, passageways that could connect distant regions through more compact routes. These were the wormholes, and suddenly, for the first time, there seemed to be a theoretical possibility that maybe, just maybe, we could overcome the cosmic distance barrier. Maybe the universe, in all its infinite complexity, had built in some kind of loophole, some way around the apparent limitations. The idea captured imaginations. Scientists began seriously studying wormholes. They explored the mathematical properties. They investigated what conditions would be necessary for wormholes to form and remain stable. They contemplated what it might mean for space travel and human exploration. And alongside the scientific investigation, wormholes entered popular culture and imagination. They appeared in science fiction stories and novels. They became symbols of possibility, of transcendence, of the hope that human beings might one day break free from the gravity well of our home planet and explore the cosmos. The wormhole represented freedom. It represented hope. It represented the possibility that our limitations weren't actually absolute. This is deeply important to understand because the dream of wormholes wasn't just an idle speculation by theoretical physicists. It was rooted in something fundamental, the human refusal to accept barriers as permanent. We've always found a way around. We've always innovated, adapted, discovered new technologies and new approaches. So when Einstein's equation suggested that wormholes might be possible, it felt like maybe we'd found the next innovation, the next breakthrough that would open the cosmos to us. It felt like the universe was offering us a gift, showing us that the barriers we perceived might not be absolute after all. And there's another element to this story that we need to appreciate. The specific barrier that the wormhole seemed to promise to overcome was the speed of light itself. Now, the speed of light isn't just any barrier. It's not like trying to go faster than a jet airplane, where there's no fundamental limit and it's just a matter of engineering and technology. The speed of light, according to Einstein's relativity theory, is a fundamental constant of the universe. Nothing can travel faster than light. It's not forbidden by our current technology or our lack of engineering skill. It's forbidden by the very structure of space-time itself. It's built into the equations that describe how the universe works at the most fundamental level. This seems unfair to us in some way. It seems like an arbitrary limit, a rule that the universe has imposed on us that we should be able to find a workaround for. If only we were clever enough, if only we could find the right loophole, maybe we could bypass this limit. Maybe we could travel faster than light. And this is where the wormhole became so seductive, so appealing to our imagination. Because if you could use a wormhole to take a shortcut through space, if you could fold space-time and bring distant points close together, then maybe you could effectively travel faster than light. You wouldn't be moving faster than light through normal space, but you'd arrive at your destination faster than light could arrive if it traveled the normal way. That would be faster than light travel. That would be breaking the cosmic speed limit. It's a beautiful dream. It's elegant in its way. It feels like it should work. And for decades, this hope sustained research into wormholes. Scientists kept studying them, kept refining the mathematics, kept looking for reasons why they might actually exist or how they might actually function. But here's where our story takes a turn, where it becomes more interesting and more profound. Because as the research continued, as the understanding deepened, scientists began to discover something troubling. They began to find hints, suggestions, and eventually strong evidence that wormholes, if they existed, couldn't actually be used for faster than light travel. There were fundamental barriers built into the laws of physics that seemed to prevent it. And these weren't barriers of engineering or technology. They were barriers of physics itself, perhaps rooted in something even deeper, the structure of causality and time itself. This is the mystery we're exploring tonight. This is the question that drew us into this cosmic journey. Why couldn't wormholes beat light speed? And as we discover the answer, as we uncover the reasons, we'll find something beautiful and unexpected. We'll find that the universe isn't being cruel or limiting us arbitrarily. Instead, it's protecting something deeper, something more important than speed or conquest, or the ability to traverse space quickly. It's protecting the very foundations of reality itself, the rules that allow cause and effect to exist, that allow time to flow forward, that make the universe coherent and comprehensible. But before we get to those answers, before we reveal the deep physics behind why wormholes couldn't escape the light speed limit, we need to understand more deeply what that light speed limit actually is and why it matters so much. We need to explore why Einstein's universal speed limit is so different from any other speed limit we might encounter in our lives. And we need to contemplate what it means that the universe seems to be fundamentally limited in this way, what it means for us as a species, and what it might tell us about the nature of reality itself. If you're still with me, if this cosmic contemplation is drawing you deeper into wonder, if you're finding yourself fascinated by these mysteries, please let us know. The comment section is waiting for your thoughts. What have you found most interesting so far? Is it the idea of wormholes themselves? Is it the dream of overcoming cosmic distances? Is it the philosophical question of whether we can escape our limitations? Your thoughts matter. They add to this cosmic conversation, and each comment is like a small star, a point of light in the darkness of space, connecting minds across vast distances who are all contemplating the same mysteries, all wondering about the same questions. The night grows deeper. You may feel yourself drifting, and that's beautiful. Let yourself float on these ideas. Let the cosmic perspective settle over you like starlight. The universe is vast and old and far stranger than we can fully imagine. And you, listening to this, contemplating these mysteries, are part of that universe. You're made of stardust, literally. Every atom in your body was forged in the heart of a star. You're connected to all of this. These aren't abstract questions. They're about us, about our nature, about our place in the grand cosmic design. The light-speed barrier stands before us now like a cosmic wall, vast and insurmountable, yet elegant in its inevitability. To understand why wormholes could never truly beat light speed, we must first come to understand what this barrier actually is, what it means, and why it seems to run so fundamentally through the fabric of existence. You see, the speed of light isn't something that was discovered accidentally, like how we might find a speed limit sign on a highway. Rather, it emerged from the very mathematics that describe the universe itself, from Einstein's theory of general relativity. It's not a limitation imposed from outside. It's intrinsic to how space-time works, how reality itself is structured at the deepest level. Let me paint a picture for you, a way of understanding this that might help illuminate why light speed matters so profoundly. Imagine the universe as a great tapestry, woven from threads of space and time. Now, on this tapestry, there are certain patterns, certain rules about how things can move through it. One of the fundamental discoveries of physics in the 20th century was that space and time aren't separate. They're not two different things. Rather, they're aspects of a single reality, space-time. And within this space-time, there are paths, trajectories that different objects and different forms of energy can take. A massive object like you or me, or a spacecraft, can follow one kind of path through space-time. Light follows a different kind of path. And the speed of light, that constant 300,000 kilometers per second, marks a fundamental boundary between these different types of paths. Here's something deeply important to understand, that 300,000 kilometers per second isn't just the speed at which light happens to travel. It's far more fundamental than that. The speed of light is actually the fastest speed at which causality itself can propagate through the universe. It's the speed at which information can travel from one place to another. It's the speed at which one event can influence another event in a distant location. When a massive object like a planet moves, it doesn't instantly affect distant objects. Instead, its influence propagates outward at light speed. When you accelerate, when you change direction, that change doesn't instantly ripple through the entire universe. It spreads outward at light speed, no faster. This is why Einstein called light speed the ultimate speed limit. It's not that nothing can go faster than light, because we haven't invented good enough rockets. It's that anything faster than light would violate the basic causal structure of the universe. It would allow effects to precede causes. It would allow time to flow backward in some reference frames. It would break the fundamental logic of reality itself. Consider what would happen if you could travel faster than light. Imagine you could somehow accelerate to, say, twice the speed of light. You would journey to a distant star, arrive there, and then begin your journey home. According to your experience, you would leave Earth first and arrive at the star second. But here's where it gets strange. Due to the way time works in relativity, according to observers on Earth, events would appear to happen in a different order. To them, you would appear to arrive at the distant star before you left Earth. You would seem to travel backward in time relative to them. More troubling still, if you could send a signal back to Earth faster than light, you could, in theory, send information backward in time. You could receive messages about future events. You could create paradoxes where you prevented the very conditions that led to your sending the message in the first place. These are called causality violations, and they would tear the logic of reality apart. The universe, in its deep structure, appears to have evolved in such a way as to prevent these paradoxes. The light speed barrier isn't just a speed limit, it's a protection mechanism. It's a way of ensuring that cause and effect always flow in the same direction, that time remains coherent, that the universe doesn't collapse into logical contradiction. This is why no massive object can reach light speed. The closer you try to accelerate something with mass, the more energy it requires. As you approach light speed, the energy required grows asymptotically toward infinity. You would need infinite energy to accelerate any object with mass to light speed. It's not a limitation of our current technology. It's not something we could overcome if we just had better rockets. It's a fundamental feature of how massive objects interact with space-time. Now, when physicists first began studying wormholes seriously, this fact was already well established. Light speed was clearly an ultimate barrier, not just for massive objects, but for causality itself. And yet, many physicists found themselves asking, would a wormhole be subject to this barrier? If you could find a wormhole, if you could traverse its tunnel through space-time, would you still be limited by light speed? Would the wormhole somehow allow you to bypass the causal structure of the universe that prevents faster-than-light travel? This question became central to wormhole research. It seemed like maybe the answer could be yes. It seemed plausible that a wormhole, by fundamentally altering the geometry of space, might create a loophole in the light speed limit. But before we can understand why this doesn't work, why wormholes cannot escape the light speed barrier, we need to understand something else. We need to understand what we mean by traveling through a wormhole in the first place. It's not as simple as you might think. When you travel through a wormhole, you're still moving through space-time. You're still constrained by the same rules that govern motion through space-time everywhere else. The wormhole doesn't change those rules. It just changes the geometry, the shape of space-time locally. And as we'll discover, this shape changing, this geometry alteration, doesn't actually allow you to bypass the light speed limit. In fact, there are deep mathematical reasons why it can't. Imagine you're standing at the mouth of a wormhole ready to journey through it. From your perspective, the wormhole might seem like a shortcut. You can see the other mouth of the wormhole nearby and you think, I'll just step through and I'll be at my destination almost instantly. But here's the thing, and this is where the real mystery begins. The distance through the wormhole, when measured properly, isn't actually shorter than the distance through normal space. This might seem counterintuitive. A wormhole, by definition, seems like it should be a shortcut, but the way space-time is structured, the way the mathematics works out, the proper distance through a wormhole is always at least as long as the distance through ordinary space, and often much longer. This is where we encounter our first hint that wormholes might not be the solution to light-speed travel that we dream them to be, but it's just the beginning. There are deeper reasons, more fundamental reasons rooted in the structure of causality and time, why wormholes cannot provide faster-than-light travel. And to understand these reasons, we need to go deeper still, into the realm of exotic physics and the very nature of time itself. We need to explore what physicists have discovered about the relationship between wormholes and causality, between space-time geometry and the arrow of time. But before we dive into those deeper waters, let's pause for a moment and reflect on what we've learned so far. We've established that the speed of light is not just a speed limit like a highway speed limit. It's fundamental. It's rooted in the very structure of causality and time. It's the speed at which cause can influence effect, at which information can propagate, at which the universe's logic remains coherent. We've begun to see that wormholes, despite their promise as shortcuts, might not actually bypass this fundamental limitation. And we've started to understand that perhaps, just perhaps, the reason wormholes can't beat light speed isn't a failure of the universe or a cruel limitation. It might be that the universe is protecting something even more important than speed or conquest. It might be protecting the coherence of reality itself. This is a profound thought to sit with as you continue on this journey. The universe, in its infinite wisdom and complexity, seems to have structured itself in such a way that certain things are possible and certain things are not. Faster-than-light travel, whether through wormholes or any other means, appears to be in the category of things that cannot be. Not because we haven't invented the right technology, not because we're not clever enough, but because allowing such travel would require breaking the fundamental causal structure of reality. And the universe, it seems, is not willing to do that. The universe has chosen order, coherence, and causality over speed and conquest. And perhaps there's something beautiful in that choice. Now let's move deeper into the exploration of what exactly happens when you attempt to use a wormhole for rapid transit, and why the mathematics consistently reveals that such rapid transit is impossible. This is the territory where science becomes almost poetic, where equations and logic combine to reveal surprising truths about the nature of reality itself. The journey through these ideas might feel complex, but I encourage you to let the complexity wash over you. You don't need to fully understand every detail to appreciate the beauty and significance of what the mathematics reveals. Sometimes, it's enough to sense the deeper truth, to feel the way that reality seems to protect certain fundamental principles even as we search for ways around them. Consider what happens when physicists describe the motion of an object through a wormhole using the equations of general relativity. They must define what is called a world line, a path through space-time describing how an object moves from one moment and location to another. Every object in the universe has a world line. Your world line stretches from your birth to this present moment and extends into your future. Light has a special type of world line, called a light-like world line, or null world line, which travels at exactly the speed of light. Massive objects have time-like world lines that always travel slower than light. Now, the crucial insight that physicists discovered is this. When you attempt to construct a traversable wormhole, one that you could actually travel through, and you try to define a world line for an object traveling through that wormhole from one mouth to the other, something very strange happens. If you try to make that journey faster than light would travel through the same points in spacetime, you encounter what's called a closed time-like curve. This is a world line that loops back on itself in time. This is a time travel curve, and time travel curves lead directly to causality violations, to paradoxes, to the kind of logical contradictions that seem to tear at the fabric of reality itself. This is the deep reason, the fundamental reason, why wormholes cannot be used for faster-than-light travel. It's not just that they don't work in practice, it's that they can't work in principle. If a wormhole were structured in such a way that you could traverse it faster than light, then time travel paradoxes would become possible. Someone could travel through the wormhole, journey back in time, and potentially prevent the very conditions that led to the wormhole's creation, or to their own travel. The universe would become logically inconsistent, and the universe at its deepest level seems to be structured in a way that prevents this. It seems to be structured in a way that protects logical consistency at all costs. There's a physicist named Stephen Hawking who proposed something called the chronology protection conjecture. Hawking suggested that the laws of physics might contain some mechanism that prevents time travel paradoxes from actually occurring in the real universe. He proposed that even though Einstein's equations mathematically allow for closed time-like curves, the kind of paths through space-time that would allow time travel, there might be some yet unknown physics that prevents these curves from actually forming in nature. The conjecture isn't proven, but it's based on the observation that the universe seems remarkably free of paradoxes and logical contradictions. It seems as though reality is protected against the possibility of causality violations. Now, how does this protection work? One possibility is that wormholes, if they form at all, might be prevented from becoming traversable. A wormhole could exist as a mathematical solution to Einstein's equations, but the actual physical processes that would be required to keep it open and stable might be impossible. The exotic matter with negative energy density that would be needed to prop open a wormhole might not exist in sufficient quantities, or it might violate some other principle of physics. Another possibility is that if you try to use a wormhole for faster-than-light travel, some physical process, perhaps quantum effects, perhaps something we don't yet understand, would intervene to prevent it. The wormhole might collapse, radiation might build up, something would go wrong exactly at the moment when you tried to violate causality. This is deeply fascinating because it suggests that reality itself has defenses against logical contradiction. It suggests that the universe is not only governed by the laws of physics, but also by some deeper principle that preserves coherence and logic. Causality is not just another physical law that we can choose to violate if we're clever enough. It's a foundational principle of reality itself, and the universe, in its infinite wisdom, has built-in protections to ensure that this principle is never violated. So what does this mean for our dream of exploring the galaxy? What does this mean for the hope that wormholes might offer us a way to escape the cosmic distances that separate us from the stars? Well, it means that we must accept a fundamental truth. We cannot use wormholes or any other technology to travel faster than light. We cannot escape the speed of light barrier, but here's the thing, and this is where the story transforms from one of disappointment to one of peace and even wonder. Accepting this limitation might be exactly what we need to do. It might be exactly what the universe intends for us. Because here's another thought to contemplate as you drift deeper into the night, as the world around you grows quieter and your mind begins to settle towards sleep. Perhaps the speed of a light limitation is not a curse, but a gift. Perhaps the universe, in preventing faster-than-light travel, is protecting us. It's keeping us contained within a region of space. preventing us from scattering across the cosmos so far that we lose our connection to home, to Earth, to the place where our species originated. It's keeping us together, in a sense, bound by the cosmic speed limit that makes the universe local in a way that matters. Think about it. If we could travel faster than light, if we could instantaneously visit distant worlds, if the cosmos lay open to us without any temporal barrier, what would we be? We would be scattered, spread out across the universe, each colony and outpost separated from the others by vast distances, but without any sense of journey, without any sense of the time and effort required to cross those distances. We would lose something precious. We would lose the sense of connection that comes from difficulty, from the effort required to reach out and touch something distant. The cosmic speed limit, in a strange way, makes the universe meaningful. It makes exploration matter. It makes reaching out to other worlds an act of profound significance and commitment. But we're getting ahead of ourselves. We're beginning to move into the realm of philosophy and meaning, when we still have more physics to explore, more mysteries to uncover about why wormholes specifically cannot beat light speed. Let's return now to the deeper investigation of wormhole physics and understand more completely what physicists have discovered through decades of research about the relationship between wormholes and the causality structure of space-time. The mathematics of general relativity, Einstein's theory of gravity and space-time, are extraordinarily complex, but at their core they describe how matter and energy curve space-time, and how curved space-time affects the motion of matter and energy. Now, when physicists solve Einstein's equations for a wormhole, they get solutions that describe a specific geometric structure, two regions of space-time connected by a tunnel or throat. The mathematics allows for this. The equations have solutions that describe exactly this configuration. But here's what's remarkable. When physicists investigate these solutions in detail, when they try to understand what happens if you actually attempt to travel through the wormhole, they discover constraints. They discover limitations. They discover that the very structure of space-time, as described by Einstein's equations, seems to prevent faster-than-light travel through the wormhole. One of the key insights comes from something called the averaged null energy condition. This is a principle that seems to hold throughout space-time, a principle that appears to be woven into the fabric of reality. The averaged null energy condition essentially states that on average, over any region of space-time, the energy density must be positive. Now, when you try to construct a traversable wormhole, when you try to make it large enough and stable enough that you could actually fly a spacecraft through it, you need exotic matter, matter with negative energy density to hold it open. But the average null energy condition limits how much negative energy you can have. And as it turns out, these limitations are exactly what's needed to prevent faster-than-light travel through the wormhole. When you run the mathematics, when you construct a traversable wormhole that satisfies the average null energy condition and other constraints from general relativity, and then you try to describe a path through it that would get from one mouth to the other faster than light, something goes wrong. The mathematics breaks down. The wormhole would need to violate the constraints. It would need to contain regions of spacetime that violate the principles of general relativity. In other words, no consistent solution to Einstein's equations describes a wormhole through which you can travel faster than light, while still obeying all the other rules of physics. This is profound because it suggests that the light speed barrier and the constraints preventing causality violations are not separate things. They're connected. They're aspects of the same fundamental principle. The universe has structured itself in such a way that causality is protected, and this protection automatically ensures that faster-than-light travel is impossible, whether you're trying to go directly through space or whether you're trying to use a wormhole as a shortcut. If you're still following along with me, if you haven't drifted off into the peaceful embrace of sleep, I want to pause here and ask you to reflect on something. Think about what we've discovered so far. We've learned that wormholes, despite being mathematically allowed by Einstein's equations, cannot actually be used for faster-than-light travel because of fundamental principles built into the structure of space-time. We've learned that causality, the principle that cause precedes effect, is protected by the laws of physics at a deep level. And we've begun to understand that these limitations might not be curses, but rather elegant protections that preserve the coherence and logic of reality itself. This is the kind of deep contemplation that pairs beautifully with the quiet hours of night, with the gentle approach towards sleep. These are not the kind of thoughts that create anxiety or urgency. They're the kind of thoughts that create a sense of awe, a sense of peace with the way things are. They're the kind of thoughts that help us accept our place in the universe, not as a limitation, but as a participation in a beautifully ordered reality. Now, we should note that this doesn't mean wormholes definitely exist. It means that if they do exist, if they form somewhere in the cosmos through some exotic process we haven't yet discovered, they too would be bound by the same fundamental limits that bind all of reality. They too would be unable to provide faster-than-light travel. They too would respect the cosmic speed limit and the causal structure of space-time. In fact, many physicists suspect that the same physics that prevents causality violations through wormholes is the same physics that prevents wormholes from forming and remaining stable in the first place. This is an important nuance. When we say that wormholes cannot provide faster-than-light travel, we're not just saying that we haven't figured out how to use them for that yet. We're saying that it's impossible in principle, based on fundamental principles of physics. We're saying that the universe itself seems to have locked away faster-than-light travel as simply impossible, whether through wormholes or any other means, and this impossibility is not arbitrary. It flows from the deepest structures of reality, from the nature of space-time itself, from the principle of causality, from the equations that describe how the universe works at the most fundamental level. Let me paint another picture for you, one that might help crystallize this understanding. Imagine the universe as a vast game, governed by certain rules. The rules are strict and absolute. They cannot be violated or bent. One of the fundamental rules is that causality always flows forward, cause always precedes effect. Time always flows forward, never backward. These rules are enforced not by some external force, not by some cosmic police officer, but by the very structure of the rules themselves. If you try to violate one of these rules, if you try to make an effect precede a cause, if you try to travel backward in time, if you try to send information faster than light, the rules themselves prevent it. The mathematics of reality itself prevents it. A wormhole is like a pathway within the game board of reality. But no matter how you shape that pathway, no matter how you curve it and fold it, you still have to obey the fundamental rules of the game. You can't travel faster than light through the wormhole because doing so would violate the rule of causality. And causality, it seems, is more fundamental than distance. It's more fundamental than the geometry of space. It's protected above all other principles. As you sit with this understanding, as you let it settle over you like a blanket in the darkness of night, you might find yourself experiencing a shift in perspective. The speed of light, which might have seemed like an arbitrary limit before, now appears as something else entirely. It appears as a protection, a safeguard that preserves the logic and coherence of reality itself. The cosmic distances, which might have seemed like a frustrating barrier to exploration, now appear as a kind of buffer, a way of keeping us grounded in place and time, connected to our origins and to each other. There's something deeply comforting in this realization. It means that the universe is not broken. It means that we haven't just failed to find the right loophole yet. It means that the universe is fundamentally coherent, fundamentally logical, and fundamentally safe. It means that reality is built on principles so deep and so solid that they cannot be subverted or circumvented. And we, as conscious beings capable of understanding these principles, are living within a reality that makes sense, that makes deep sense. If you're still here with me, if you're finding resonance in these ideas, if you're feeling that sense of cosmic wonder mixed with peaceful acceptance, please let us know. What aspect of this discovery speaks most deeply to you? Is it the idea that causality is protected? Is it the realization that wormholes can't provide the escape we dreamed of? Is it the sense that the universe is coherent and logical? Your thoughts matter. Your perspective matters. Each person who contemplates these mysteries adds something to our collective understanding. Each person who asks these questions contributes to the great conversation of humanity about our place in the cosmos. The night continues its quiet progression. You may find yourself becoming drowsy, and that's perfect. That's exactly the state of consciousness that pairs beautifully with these cosmological contemplations. The boundary between waking thought and dreaming mind becomes soft and permeable. And in that space between, ideas can settle into us on a deeper level. Understanding can take root not just in our rational minds, but in our intuition, in our sense of what feels true and right and real. Let's now venture into even deeper territory, into the realm of implications and meaning. We've established the physics. We've shown that wormholes cannot provide faster-than-light travel, because doing so would violate fundamental principles of causality embedded in the structure of space-time. But what does this actually mean? What are the implications of this discovery for us as a species, for our understanding of the universe, and for our place within it? First, let's acknowledge what this means in practical terms. It means that no matter how advanced our technology becomes, no matter how clever our engineers are, we will never be able to use wormholes to reach distant stars in times that seem reasonable from a human perspective. The galaxy will remain vast, the distances will remain immense. A journey to even the nearest star system would require years of travel time at minimum, and journeys to the distant reaches of the galaxy would require centuries, millennia, or longer. The cosmos will not open up to us as a frontier to be quickly conquered and colonized. The stars will remain distant. The universe will remain largely beyond our reach. But here's the profound paradox. That's okay. More than okay. It might be exactly as it should be. You see, when we step back from our immediate desires and frustrations, the wish to go faster, the wish to overcome every barrier, the wish to conquer and explore and expand without limitation, and when we look at the bigger picture, at the deep structure of reality itself, we can see that there's a kind of wisdom in these limitations. Consider what the universe might be like if faster-than-light travel were possible. Consider what human civilization might become if we could scatter across the galaxy at will, establishing colonies on distant worlds, separated by no meaningful time, able to communicate instantaneously with Earth and with each other. In one sense, this seems wonderful. It would represent the ultimate freedom, the ultimate expansion of human potential. But in another sense, it would represent a fundamental disconnection from the place we come from the world that created us. Our home planet, Earth, would become just one-way station among millions. The precious uniqueness of our origin world would be diluted by the vastness of available space. We would lose something profound in the process. We would lose the sense of journey, the sense that reaching out to other worlds means something, that it requires commitment and sacrifice and courage. Moreover, and this is crucial, if faster-than-light travel were possible, if causality violations were allowed, then the timeline of the universe would become convoluted and paradoxical. Time travel paradoxes would not be theoretical puzzles discussed by philosophers. They would be practical problems that could actually occur. Someone could travel to the past and prevent their own birth. Someone could kill their grandmother before she gave birth to their parent. Someone could create situations of logical contradiction that would seem to tear reality apart. The universe would not be coherent. History would not have a clear timeline. Cause and effect would become hopelessly tangled. The fact that the universe prevents all of this, the fact that causality is protected at the deepest level, the fact that the speed of a light barrier ensures that time always flows forward and that cause always precedes effect, this is not a limitation. This is a feature. This is the universe protecting something precious, its own coherence, its own logical integrity. This is reality ensuring that it remains real, that it remains a coherent whole, rather than dissolving into paradox and contradiction. Now, what does this mean for us? What does this mean for human exploration and human destiny? Well, it means we must accept that the cosmos will not be conquered through speed. It means we must accept that other worlds and other star systems will remain distant, remain unreachable except through journeys measured in years or decades or centuries. It means that for the foreseeable future, humanity will remain essentially bound to Earth and the near reaches of our solar system. And perhaps this is the lesson that the universe is trying to teach us. Perhaps the universe is telling us, don't worry about conquering other worlds. Focus on the world you have. Learn to live in balance with this world. Understand your place within the ecosystem of this planet. Appreciate the extraordinary miracle of life here, the intricate web of relationships between all living things that has taken billions of years to develop. The universe is telling us, you have enough, your world is enough, your work is here. There's a concept in astronomy and cosmology called the cosmic perspective. It's the idea that when you contemplate your place in the vast universe, when you consider that Earth is just one planet orbiting an ordinary star in one ordinary galaxy among billions of other galaxies, you gain a sense of humility and perspective about your own importance. You realize that you are simultaneously insignificant and precious, that your life is both a tiny speck in an incomprehensibly vast cosmos and also a unique and irreplaceable expression of consciousness and awareness. The cosmic perspective often leads to a shift in priorities. When you truly grasp the scale of the universe, when you really understand how vast and old and complex it is, you often find that your concerns about status and wealth and power seem smaller. You find that the relationships in your life, the connections you have with other people, the love you share, the conversations you have, the moments of beauty you experience, these things seem more significant. You find yourself caring more about preserving and protecting the precious biosphere of Earth, more concerned about living in harmony with the natural world, more focused on the present moment rather than endlessly striving toward future conquests. Perhaps the cosmic speed limit, the barrier that prevents faster-than-light travel, is the universe's way of forcing us toward this cosmic perspective. Perhaps it's the universe's way of saying, you cannot escape into distant space. You must deal with the world you have. You must learn to live here on this planet with these people in this moment. And in that acceptance, in that focus on what is rather than what could be, there is profound peace. This is a beautiful thought to contemplate as you drift towards sleep. The universe is not preventing us from doing something wonderful. It's inviting us to pay attention to what's already here. It's inviting us to find wonder and meaning, not in the future conquest of distant stars, but in the present appreciation of the precious world we inhabit. It's inviting us to see that we don't need to escape to find paradise. Paradise is already here, in the blue skies and green forests, in the eyes of people we love, in the quiet beauty of a moment when we're fully present and aware. Now, let's consider another implication of the discovery that wormholes cannot beat light speed. It speaks to something fundamental about how the universe protects its own structure and integrity. The physicist Roger Penrose proposed something called the weak cosmic censorship conjecture. This is the idea that the universe is constructed in such a way that certain causal structures, like naked singularities or closed time-like curves that would lead to time travel paradoxes, cannot form in the real world, even though they are allowed by the mathematics of general relativity. What this suggests is that there's a layer of protection built into the laws of physics beyond just the equations themselves. The equations might mathematically allow for time travel and causality violations, but some deeper principle prevents these solutions from actually manifesting in nature. When physicists investigate this protection more closely, they find hints that it might be connected to quantum mechanics, to the behavior of matter and energy at the smallest scales, or to some yet unknown principle that we haven't fully grasped. This is where our understanding reaches the edge of what we know. We can describe the mathematics that shows wormholes can't provide faster-than-light travel. We can explain the principle of causality that forbids such travel, but we don't fully understand the mechanism by which the universe enforces these principles at the deepest level. We don't completely understand what happens if you tried to construct a wormhole and use it to violate causality. Would it simply fail to form? Would it collapse at the critical moment? Would something else intervene? What we do know is that the universe seems to have redundant protections against causality violations. There's the mathematical prohibition, the fact that the equations governing wormholes make faster-than-light travel impossible. There's the thermodynamic prohibition, the fact that exotic matter with negative energy density seems to be extremely rare and difficult to produce. There's the chronology protection conjecture, which suggests that additional physical processes might prevent causality violations from occurring even if the basic mathematics seem to allow them, and there are probably other protections that we haven't discovered yet. This redundancy itself is significant. It suggests that preserving causality, maintaining the flow of time, preventing paradoxes and logical contradictions, all of these are so important to the functioning of the universe that multiple safeguards have been built in. The universe isn't just hoping that causality violations won't happen, it's working very hard to prevent them. This dedication, this commitment to protecting logical coherence, tells us something profound about what the universe values most. It values order, it values logic, it values coherence and consistency. These things are more important than speed, more important than expansion, more important than our desire to go anywhere quickly. The universe has chosen to build itself in such a way that these abstract principles are protected above all else. And in doing so, the universe has also protected us. It has protected us from the chaos and confusion that would result if time could flow backward, if causality could be violated, if paradoxes could actually occur in the real world. This is the deeper meaning of why wormholes cannot beat light speed. It's not just a technical limitation, it's a statement about what the universe is and what it values. The universe is fundamentally a place of order and logic. And we are beings capable of understanding that order and logic, capable of appreciating the deep coherence of reality. We are part of the universe, and in contemplating these deep truths, we're essentially contemplating the nature of our own being. If you're still with me, if you're feeling the weight and wonder of these ideas, if you're beginning to understand that the cosmic speed limit might not be a barrier but an invitation to find peace with the world as it is, to appreciate what we have rather than endlessly reaching for what we cannot have, then please share that with us. What does this realization mean to you? How does it change your perspective on the universe and our place in it? Your comments are like beacons of light in the vast darkness. They tell us that there are others out there, others contemplating the same mysteries, others seeking to understand the nature of reality. And there's something profoundly moving about that connection across distance and difference. Even though we're separated by physical space, even though we might be in different parts of the world watching at different times, we're all participating in the same great conversation about existence and meaning, and our relationship to the cosmos. The night grows late. Your eyelids might be growing heavy. The boundary between waking and sleeping might be becoming increasingly blurred. This is good. This is exactly the state of consciousness that allows for deep learning and deep integration of ideas. In the space between waking and dreaming, our minds work differently. We can hold multiple possibilities at once. We can feel the emotional truth of an idea while also understanding its intellectual content. We can allow profound realizations to settle into us on a level deeper than pure reasoning. So let yourself drift now. Let the cosmic perspective settle over you. Let the understanding that the universe is coherent and logical and protected and safe settle into your bones. You are part of this universe. You are made of the same matter and energy that makes up the stars. You are a manifestation of the same cosmic principles that govern the motion of galaxies. And in this moment, in this quiet night, you are connected to all of it. You're connected to the vast distances between stars. You're connected to the flow of time. You're connected to the fundamental principles of logic and causality that make reality coherent. And you are safe. You are held within a universe that makes sense.